Now let's look at motion in one dimension in this video. Now we'll be considering the motion of a particle in one direction, whether x-axis or y-axis, just in one direction. Now, let's take a look. The first aspect of this we'll be explaining is the displacement. Observe, if I have 2 points, let me say the 2 points are A and I have B, and a particle moves and takes this curve like this, moves this way and takes this curve like this. Can you tell me? You know that the straight line joining the starting point A to the terminal point B is this straight line here. Good. All right, and the straight line will be directed like this. Now, looking at what I'm having here, you will get the difference between distance and displacement here. You know, the distance traveled by this object will be what? Will be the length of this curve here, because this is the actual point where the object was moved. But what is displacement? Displacement is just the straight line that is drawn from what? From the starting point to the what? To the terminal point. So that is it. And you observe from here, you always see that what? Distance will always be more than displacement. Can you see? Exactly. So that is it. And take note that what? This point, which is the starting point, I can call it x initial. That is the initial position of the object. While this point is what? X final, which is what? The final position of the what? Of the object. Now, what is now the displacement of this object? How do we calculate displacement? Now, the displacement is given as delta x is equals to what? X final minus x initial, or you can see some books will say x2 minus x1. And that is what we call displacement. The final position of the object minus the initial what position. Now, next one. What is now the average velocity of the object? Take notes. Average velocity VAVG is equals to what? The displacement over the time interval. So I can say x final minus x initial over t final minus what? C initial. And that is what? Average what? Velocity. Take note that what? Average velocity, also displacement, they are both vectors. So it means that they can have plus sign and they can have minus sign. So if in this time, okay, let me say if x now, if this displacement have a positive sign, it means that it is moving at the positive x-axis. But a negative sign shows that it's moving in opposite direction. So they can both have plus and minus. So displacement can have negative, but distance is always positive. You see distance? Distance is always positive. Distance is always positive. And again, looking at this diagram, can I say the distance is the magnitude of the displacement? No, it is not the magnitude of displacement, because if you look at it, this distance here, this length here will be more longer than this. So it's not the magnitude of the displacement. Please take note of that. Distance is always positive, but displacement can take both positive and negative because it's a vector quantity, same as what? Average what? Velocity. Now, what is now average speed? Let me use VSAVG for average speed. You know, average speed relates distance. So total distance all over the time interval. So I can say total distance over delta t, and that is what? Average speed. Average speed, you know, relates distance. You see, distance is a scalar, average speed is a scalar, so they'll always be positive. Displacement is a vector, average velocity is a vector. Now, what do we call the instantaneous velocity? What do we call the instantaneous velocity? You see, let's say instantaneous velocity and speed. You see this word instantaneous. See, look at this part. You see that here, this average velocity is what? We are actually looking at the velocity of an object along a particular time interval. Let me say I have a graph like this. Just focus on this. And I have an object whose graph is like this. Now observe. Let me say I want to find the average velocity. So I'll be taking, let me just say 2 points. So I can take average velocity between what? These two separate points. But the instantaneous velocity is not, doesn't have time interval. is at a particular instance of time. Are you there? That's the velocity of a particle at a particular instant of time. So nothing like x final and x initial. You see, let me tell you, under instantaneous velocity here, our delta t will shrink to zero. Take note of this. Because instantaneous is that we are finding the velocity at what? At a particular point in time, not at t final and t initial. We are just taking in consideration just one particular instant of time, and that is why this delta t will shrink to what? To zero. And take note, another word for average velocity is simply velocity. So if they ask you to find velocity, note that it is instantaneous velocity. Okay, good. So how do we define instantaneous velocity? Instantaneous velocity. Instantaneous velocity is what? Let me just use v instant. Let me just use v. For instantaneous velocity, how do we define it? We take the limit as this delta t shrink to zero of the what? Of the average velocity. Remember, for the average velocity, we look at time interval to calculate the average velocity. But in instantaneous velocity, at a particular instant of time where there is no time interval, so this one will shrink to zero. And in calculus, the definition of this is equals to dx dt. That is it, dx dt. So it means that whenever we are asked to calculate velocity or instantaneous velocity, we'll be differentiating by calculus. Okay, good. All right. And take note that, so that just take note of that. So that is it. And take note that what the speed is the what is the magnitude of the instantaneous velocity. That is, speed is the what? Magnitude of instantaneous velocity. That's it. So let's look at acceleration. Let's look at acceleration. Now, so we're looking at average acceleration at the same time instantaneous acceleration. We already know acceleration is what? The time rates of change of velocity, and my average acceleration will be equal to what? The change in velocity over the time interval, and that is it. So this is it, delta v over delta t. And what is instantaneous acceleration? Remember, instantaneous acceleration will be simply called acceleration, and it will be equal to what? dv dt. Just like the way this one changed to dx dt, this one changed to what? dv dt. And take note of something, guys. See, remember that I said a equal dv dt. And take note that I can still, you know that velocity is still what? Is same thing as what? Dx dt. Do you see that? So I can write this as d square x over dt square. Take note of this. D square x over what? Over dt square. So that's another way to find what? Acceleration. Now, it means that if they are giving me x as a function of t, so if I find dx dt, this will give me velocity. And if I find the dx dt again, that's d square s over dt square, I'll be having acceleration. And that is it. So take note, if I find the first derivative of our velocity, if I find the second derivative of our acceleration, similarly, if I want to reverse, opposite of differentiation is integration. If I want to reverse, it means that my velocity will be equal to what? The integral of the acceleration, a c dt plus c, integral of the what? Of the acceleration. And also, if I want to find what? X will be equal to what? The integral of the velocity, and that is it. So that's that about that on motion in one dimension. So this is the first part which has been summarized there. So let's see some solved problem. Let's solve some problem. Now, the first one, they said the position. They said the position. They said the position of an object moving in the straight line is given as this. So solution. So you have x equal 3t square minus 4t square. Oh, sorry, 3t square minus 4t plus t cube. Let me cross check that. Three t minus 4t square plus t cube. Sorry, 3t minus 4. So that's a typo error. So x is what? 3t minus 4t square plus t cube. Now, this is what we have. So x is in meter and t is in what? Is in seconds. So we are asked to determine the displacement between these two time interval. So this is what we will do. Firstly, the initial displacement is for the initial time here. Substitute t equal to 0. That's at t equal to 0. What we have, that's 3 times 0 minus 4 times 0 square plus 0 cube. And everything we are given was 0 meter. And what's my final displacement? I'll get my final displacement at t equal 4 seconds. So anywhere you see t here, put 4 seconds. So I have 3 times 4, 3 times 4 minus 4 times 4 square, then plus 4 cube. So what will I have here? So what I'm going to get here will be, so what I'm going to get here should be, so that should be 12. That's 12 minus 64 plus, that's 12. That's 12 meter. Now, this is when you substitute t equal to 0, you get your initial displacement. When you substitute t equal to 4, you get your final displacement. So therefore, my displacement will be equal to what? SF minus XI. That's the initial position, final position minus initial position. So this one gives me 12 minus 0, and answer is 12 meter. So that's that. Next one, what is the average velocity for the time interval t equal 2 seconds and t equal what? 4 seconds. Remember, our average velocity is equals to what? The change in x over change in t. Now, firstly, we have time t equals, remember that x is equals to 3t minus 4t square plus t cube. 3t minus 4t square, 3t minus 4t square plus t cube. Now, we have these two time intervals. So substitute at t equal to 2. What's the initial displacement? This will give me 3 times 2 minus 4 times 2 square plus 2 cube. So what will this one give me? 3 times 2 is 6 minus. This will give me 16 plus 8. So minus 2. So I have minus 2 meter. Then at t equal 4 seconds, so my final displacement will be, my final position rather, it will be what? 3 times 4 minus 4 square, then plus 4 cube. So this will give me 12 or 12 meter. Now, how do we now get my average velocity? So take note that what my average velocity will be equal to, what is the change in this one? Remember, this is x final minus x initial over tf minus ti. So this one give me 12 minus xi is minus 2 over time is of 4 minus 2. So this will give me minus times minus is plus. That will give me 14 divided by 2, and that will give me 7 meter per second. That is the average velocity, 7 meter per second. So that's that for the question. Next question is this. They said that a particle is moving along the x-axis with the position given by, I have x to be equal to 3t squared minus 16t plus 8 minus 16t plus 8. What are the velocity and acceleration? Remember, what's velocity? What's acceleration? If they simply tell you velocity or acceleration, you are finding instantaneous velocity. For acceleration, you are finding instantaneous acceleration. You can see at t equal 4 seconds, you can see this is a particular instant of time. They will not give you at t equal this and this. No, a particular instant of time. Now remember, to find your velocity, that's the x dt, that differentiate with respect to t. How do you differentiate? Use the coefficient to multiply the power and subtract 1 from the power. 3 times 2 will give me 6. Subtract 1 from the power, you have t to the power of 1. Okay, and for 16t also, if I multiply this by this, I will have 16 If I subtract 1 from the power, I have 0. 3 raised to the power 0 is 1. 1 times 16 is 16. And when you are differentiating, 8 is a constant, so we don't differentiate it. So we just take 3 as 0. We don't differentiate a constant. So this is what I have, meter per second. Now, at t equal to 4 seconds, so my velocity will equal to what? Now, anywhere you see t, you put 4, so minus 16. So 6 times 4 is 24, minus 16 will give me 8. So I have 8 meter per second. And what is the acceleration? Remember, acceleration is what? When I differentiate twice. When I differentiate what? Twice, I'll have acceleration. So my acceleration is what? D square x over dt square. That is what you have here. Differentiate it again. What will you have? If you differentiate 60, you have 6. This one is a constant, it's not. So, like I said, I just have ordinary 6. So, I'll just have meter per second squared. You observe, after differentiating, I have just 6. There is no t present there. Assuming there is t present there, I will substitute t equal 4. So, this is what I have. Next question. The position of a particle moving along the x-axis is given by x equal 2t cubed minus 60 plus 5. Then where x is in meter and t is in second, find the acceleration of the particle at t equal to second. What's acceleration? Remember, I will differentiate twice. So that's d square x over dt square. That's d square x over dt square. That's acceleration. Now, I'll differentiate twice. So firstly, if I differentiate once, I'll be having this one give me multiply, that will give me 6t squared minus this one give me 6. This is a constant, I won't differentiate. So if I find the acceleration, remember that I differentiated once. Then for me to differentiate the second time, I'll differentiate again. This will be giving me, so if I differentiate again, I will exhaust this. I'll have, this will give me 12t. This is a constant 0. So at t equal 2 seconds, so my acceleration will be equal to 12 times 2, and that will equal to 24 meter per second squared. That is the acceleration. Now, is the velocity changing? Is velocity constant or changing with time? How do we answer the question? From here, if I find the velocity, dx dt, my answer will give me what? 6t squared minus 6. Now, how do we answer the question from here? Take note of something. If in your velocity you have t present there, it means that it's changing with time. If t is not present there, it means that it's not changing with time. But look at it. T is present in the velocity, so therefore the velocity is changing with time. It makes sense because if I have time to be 1 second now, it give me value. If I have time to be 3, 4, 5, I'm getting different velocity. It means that it's changing with time. Next, the acceleration of a particle is given by this. So the acceleration is given by 2 meter per second square. I'll just remove the unit. So I just have 2. This is just a unit, then t squared. This is what I just have for the acceleration, 2t squared. Now, if the particle is at rest at t equal to 0, find the velocity of the particle after 2 seconds. Okay? Now, the thing is that we want to find the velocity of the particle. Remember what I told us, that velocity is the integral of our acceleration plus c. So velocity equal to what? Let us integrate this guy. For us to integrate, we are going to add 1 to the power and we'll divide by the power. What am I saying? Add 1 to the power 2 plus 1, then all over 2 plus 1, then that's all. So then plus c. This will give me v equal 2t cubed over 3 plus c. Now, the question told us that if the particle is at rest at t equals 0, it means that at t equal to 0, the particle is at rest, means that what the velocity is equals to 0. That's what it's telling us. So if I put it there, you see, the essence of this thing is for us to find our arbitrary constant c in integration. So I have 0 equal, this one is also 0 plus c. So my c is equals to 0. So it means that my velocity is equal to 2t cubed over 3. So this constant is 0. So this is my velocity, meter per second. Now, let's say find the velocity at t equal to 2 seconds. So at t equal to 2 seconds, so my velocity is equal to 2. Anywhere you see t, you put 2. So I have 16, that's 16 over 3. So you can change that to decimal yourself. That's meter per second. So that's correct. Next question. They said the acceleration, I think this is the last question. Okay. They said the acceleration is given as a function of time as this. A equal 2 minus 1t. So let me just say 2 minus t meter per second square. If the position and velocity at time t equal to 0 are this and this, so they said that at t equal to 0, our position equal to 0 and velocity equal to 10 meter per second square. These things are just initial. Okay. What is the velocity of the car at this? No problem. Remember, velocity is what? Integral of acceleration dt plus c. So integrate this. Under integration, if you integrate a constant, I'll be having like 2t minus integrate this will give me t square over 2 then plus c. Now, they told us that at t equals 0, v equal 10. So I have 10 equal at t equals 0. This is also 0. So therefore, c equal to what? 10. So the expression for my velocity now v equal 2t minus t square over 2 plus c is 10. Now, we are done with that part. Then after that, we'll find the velocity at t equal 2 seconds. At t equal 2 seconds, what that are v equal, anywhere say t put 2. So this will give me v equal 4 minus, this will give me 2, this will give me 10, and my answer will equal to what? 12. My answer is equal to what? 12 meter per second. So that is the answer. So that's the end of this video. I believe you're able to get the concept very clear. So comment on this video, share to your friends, like and subscribe. Thanks for watching. Bye.